Hello dear friends, last time we completed chapter number 1. Today we are going to see chapter number 2, inverse trigonometric functions. Here, last time we already seen in a function how to find inverse of function. How to find inverse of function. We know that if f from a to b is 1, 1 and 1, 2, then f inverse exists. And f inverse is from where to where? B to A. Also, keep one thing in mind, F composition with F inverse is equal to identity function on domain of F inverse, that is B. And F inverse of F is equal to identity function on domain of F, that is here. Today we are going to use this concept. Please here. See, we already seen in 11th science, see, trigonometric functions, see, sine function is from where to where? Close, R is close interval -1 to 1. Here, see, this function is not 1, 1 and 1. Of course it's 1, because this is the, see, this function is 1 because that is the range of sine function. That is also the range of cos function. And see, this is the range of tan function, range of cot function. This is the range of sec and range of cosec. So codomain is same as to range. So that function is 1. See, here not equality but minus sign. Here minus. That we know very well. Now see, cosine function from this to r to close equal -1 to 1. This function is 1 to but not 1. So we need to restrict the domain. Here in every function we need to restrict a domain. We know that all these are the trigonometric functions. Sine, cos, tan, cot, sec and cosec were to vary. Clear? Now see here. Here, with help of graph, we are going to show that where it is 1, 1 and 1, 2. Let's see here. Next one. See. All of you please see here. See. This is the graph of y is equal to sine x. In general, graph is given to us. That is sine from r to close interval -1 is the graph of this function. Clear? But see, this function is not 1, 1. Why? Sine 0 is 0, sine pi is 0, sine 2 pi is minus, sine minus 2 pi is also 0, sine 0, 0, sine pi 0, sine 2 pi 0, like this. So this function is not 1, 1. Why? Sine 0 is same as sine pi. See? Sine 0 is same as sine pi. That means 0 not equal to pi, even though we get this one, so that function is not 1, 1. So we need to restrict the domain. Now see from the graph, how to check it is 1, 1ness. Now see, let us see, principal part for function sine is 1, 1. That is C. Restrict this domain. Minus pi by 2, minus pi by 2 to pi by 2. See, in this part, this function is 1 because graph is not repeated. But if we consider from 0 to pi, see, so here graph is repeated. See, for this. Here function is graph is not repeated for this part, minus pi by 2 to pi by 2. So, if we write sine from close interval minus pi by 2 to pi by 2 to close interval minus 1 to 1. In that case, this function is 1, 1 and onto. So for this part, sine inverse exists. And it's from where to where? Is nothing but from close interval minus 1 to close interval minus pi by 2 to pi by 2. Now see, graphically also we can see that this is the graph of y is equal to sine. So x is equal to sine inverse y. X is equal to sine inverse y. In general, this graph is there, this one. But see, if you observe this graph, from minus pi by 2 to pi by 2, graph is drawn in dark line. So for this part, see, for this part up to this function is 1 and 1. So just we have to rotate the graph. Then we get this is the graph of y is equal to sine inverse x. Here I am explaining this graph only for how to obtain a inverse of sine function. In other words, restrict the domain of sine function so that it is 1, 1 and 1. Clear? Now see here, for this part, sine of sine inverse, sine of sine inverse, that is equal to identity function on domain of sine inverse. What is that? Close interval minus 1 to 1. That is equal to something only when that something belongs to close interval minus 1 to 1. If this one is most important form. Clear? See, how we write it? According to that form, f of f inverse is equal to identity function on domain of f inverse. And what is f inverse of f? Is equal to identity function on domain of f. So similarly, other one, sine inverse of sine some angle is equal to some angle. What is the domain of identity, domain of f? Here domain of f is close interval minus pi by 2 to pi by 2. That means something belongs to close interval minus pi by 2 to pi by 2. Clear? Now see, this is the part now see. Once again, please see here. Sine from R to R. R to, in general, sine is function from R to R. But we need to restrict, see, graph of sine lies in between minus 1 to 1. So in place of R, we can write close interval minus 1 to 1. Clear? So sine from R to close interval minus 1 to 1, that function is 1. But that one is not 1, 1. And for 1, 1ness, what we need to do? We need to restrict the domain of sine function. Similarly, here also this part, from this part to this part it is also 1, 1. From this part to this part also 1, 1. But this one is the principal part, for which the function is 1, 1. So, if we restrict the domain of sine function, close interval minus pi by 2 to pi by 2 to up to close interval minus 1 to 1, that function is 1, 1 and 1. And therefore sine inverse exists. We come back to where? B to A. Close interval minus 1 to close interval minus pi by 2 to pi by 2. So if you observe that here x and x dash axis is given, value of x and is lies in between close interval minus 1 to 1. Here, and see, this is the internal graph of sine inverse x. Now for this part, close interval minus pi by 2 to pi by 2, see, we get this part. Clear? Okay, this is the graph here. Now see here. See, according to that part, what is sine of sine inverse sum angle is equal to sum angle only when sum angle belongs to closed interval minus 1 to 1. That means if we wish to solve this one 1 by 2, then it comes out 1 by 2. Why? Because 1 by 2 belongs to closed interval minus 1 to 1. But if we want to compute sine of sine inverse 2, but we can't take 2 because 2 is not in domain here. But we can take root 3 by 2. That means sine of sine inverse sum of angle is given to us. If they are asking the value, they are giving 2 minus 1, 0 does not exist. What is the option? Does not exist. Because sine inverse is function from where to where? Closed interval minus 1 to closed interval minus pi by 2 to pi by 2. Clear? So this is not the case. Next, see here. Next part written here, which one? See, sine inverse of sine sum angle is equal to sum angle. Now see, sine inverse sine, let us consider 2 pi by 3. Now see, we can write sine inverse of sine sum angle is equal to sum angle only when that sum angle is between closed interval minus pi by 2 to pi by 2. 2 pi by 3 is greater than 90 degree. In that case, we need to simplify this thing without changing the function. So, generate sine pi minus pi by 3? Yes. So, that is equal to sine inverse sine pi by 3 because pi minus in second quadrant. In second quadrant sine function is positive. Now we can write that is equal to pi by 3 because pi by 3 belongs to closed interval minus pi by 2 to pi by 2. Is it clear to all of you? Yes. Now let us see next definition for cos inverse. See here. Now see, once again, see, we know that cos from R to closed interval minus 1 to 1 is 1 to function. Is 1 to function. That means cos inverse exists only when it is 1 1 and 1 2. So once again we need to restrict this domain. Now for principal parts here, x is equal to 0 to x is equal to pi. You can see that in this part, graph of this function is not repeated. If graph is not repeated, then that is 1. That is 1. So of course here also it is from minus pi to 0, pi to 2 pi, likewise. But this one is the principal part, for which graph is not repeated. So we can write here cos inverse. Then if we repeat this function, let's here, restrict the domain of this function. Cos from closed interval 0 to pi to closed interval minus 1 to 1. Then that function is 1 1 and 1 2. Here. So where is cos inverse? Cos inverse from closed interval minus 1 to 1 to closed interval 0 to pi. Once again see here, y is equal to cos x is given to us. So x is equal to what we get? Cos inverse y. So we can write cos inverse x is equal to y also. So you can see that that graph is like between minus 1 to 1 throughout. You observe that graph is like between minus 1 to 1. Now see, if you observe for these two lines, 0 to pi, here graph is given dark with a shadow line, see there, for this point. Okay? There, in that part, that function is also 1. Now see here, see from this one, cos of cos inverse something is equal to something from identity function or domain of cos inverse, that is closed interval minus 1 to 1. That is thing possible only when that something it belongs to closed interval minus 1 to 1. Same way, cos inverse of cos some angle is equal to some angle. Cos inverse of cos some angle is equal to some angle. Only when that some angle belongs to closed interval 0 to pi, because domain of cos. What is domain of cos here? Closed interval 0 to pi. Now suppose we wish to find cos inverse of cos 2. 2 is given in here in radian method, not in degree method. Now see, we know that pi means 3.40. So cos inverse of cos 2 is equal to 2. Why? Because 2 belongs to closed interval 0 to pi. But suppose we wish to find cos inverse cos of 3. Then what? Now see here. If we wish to find that thing, then what happens? Cos inverse cos of 3. 3, that is also 3, because 3 belongs to closed interval 0 to pi up to 3.40. Here. Now, if we wish to find cos of cos inverse root 3 by 2, that is equal to root 3 by 2. Why? Because that root 3 by belongs to closed interval minus 1 to 1. So if this once again this most important forms here, these are the most important form as far as cos function is concerned. See, next, let us see it. Y is equal to y is equal to cosec x. In general, cosec is function from where to where? R minus k pi, k belongs to z to R minus open interval minus 1 to 1. That we know. That is the cosec function. This function is 1 to, but we need to restrict the domain for one-oneness. Now see here, observe the graph, here to here. If I take this boundary 0 to pi, that is not 1, 1. If I take minus pi to 0, that is also not 1, 1. Pi to 2 pi is not 1, 1. But if we split it, see, x is equal to minus pi by 2, x is equal to pi by 2. Observe this part. Sorry, directly. Because that is not included. Cosec function for this pi by 2. Yes, that's included. See, for this part. But see, for this part it is 1, 1. Same way for this part it is 1, 1. Except 0 at 0 function is not defined. So, what we have to do? We have to restrict the cosec function, domain of cosec function. close interval minus pi by 2 to pi by 2 to r minus open interval minus 1 to 1, and here except 0, huh? That means what to where? If I take cosec function from closed interval minus pi by 2 to pi by 2 except 0 to r minus open interval minus 1 to 1. In this case, this function is 1, 1, 8, 1, 2. See here? Here, but see that for this part, minus pi by 2 to 0, because that 0 is not defined, except 0 to 1 up to minus pi by 2. Function is defined. So, for this part, function is 1, 1 and 1. And therefore, cosec inverse is defined from r minus 1 to 1 to close interval minus pi by 2 to pi by 2 except 0. Now see, how we write r minus close interval minus 1 to 1 is nothing but all the real number for which mod x is greater than or equal to 1. 1 or 2 more or minus 1 or less, that is other than closed interval minus 1 to 1. See, if you see on real line also, see, if I take minus 1, if I take 1, open interval minus 1 to 1, accept it. So what is that to that? That is from 1 to onwards. That is x greater than or equal to 1. For this part, x is less than or equal to minus 1. So we can write it that way also. Here, yes. So inverse exists for that part. Now see here. Same way here, what we want to write? Cosec of cosec inverse is equal to something that is equal to something. When? That is the identity function of cosec inverse is only when that something, magnitude of that something is greater than or equal to 1. Because see what is the range domain of this one. Same way, cosec inverse cosec is equal to something. When that something belongs to minus pi by 2 to pi by 2 except 0. Once again see here for graph. See, at 0 this function is not defined. Now here you can see that for the inverse, graph is outside the minus 1 as well as outside the plus 1. Other than this part graph is set. Once again, for this part it is not 1, 1 and 1, 2. But see, observe that here they are giving indirect line. So for this part as well as for this part, this function is 1, 1 and 1 do not define at 0. Because of course it is not defined in between minus 1 to 1 also. Here. But it defined at 1 as well as defined at minus 1. Clear? So this is the cosec inverse. See, in examination they are not going to ask the graph. But here to see that why we need to restrict the domain. This is the reason we are saying the existence of inverse on a graph vector. Here. But we have to remember only these two lines. Sorry, these two lines. Likewise, we will see sine and cos like that. Next, let us see here. This one is the graph of sec inverse x. First of all, mention that sec is function from R minus 2k plus 1 pi by 2, k belongs to Z2 R minus open interval minus 1 to 1. Here this function is 1, 2 because codomain is same as its range. Now see, this one is not 1, 1. In general it is not 1, 1. You can see that here. See, this function, if you observe that, here 1 and here minus 1. If you rotate it, like that is the graph of y is equal to cos x. Now see here, once again, for principal part, restrict this domain, y is equal to 0, y is equal to, sorry, x is equal to pi, x is equal to 0, except this pi by 2. At pi by 2, function is not defined. But if you see that this part, see here, up to this part, as well as for this part. See, for this part it is 1, 1 and 1, 2, except pi by 2. So if we define sec from close interval 0 to pi, except pi by 2 to R minus open interval minus 1 to 1. Then that is 1, 1 and 1, 2. In that case, this function is 1, 1 and 1, 2. Now see here, for the inverse part, once again see, here it is other than minus 1 and 1 from this side and this side. Now you can see that for this part the graph is shown for double line. So for this part it is 1, 1 and 1, 2 and it is not defined as. Now see for this part and this part. Here, but at pi by 2 is not defined. Let's see, at pi by 2 for this time it is not defined. So for this part it is 1, 1 and 1, 2. So basically this one is the graph of cos sec inverse. Now let us see here how to write sec of sec inverse some value is equal to that value. That is equal to 1 minute. Sec is different from where? This to this. So sec inverse is from where to where? Sec inverse is from R minus close open interval minus 1 to 1, close interval 0 to pi, except pi by 2. See, this is the definition of sec inverse. And that is equal to something only when that something is other than minus 1 to 1, open interval minus 1 to 1. That is magnitude of that should be greater than or equal to 1. Same way, sec inverse sec of some angle is equal to some angle, right? Only where that angle belongs to close interval 0 to pi, except pi by 2. Here, keep these two forms in mind. See, up to this stage, we will see existence of sine inverse, existence of cos inverse, existence of cosec inverse, existence of sec inverse. Now remaining two forms are there, that is tan and cot. Let me see that thing is also here. See. Now we can see that here. Now see. Basically tan is function from where to where? R minus 2k plus 1 pi by 2. K belongs to Z to R. Now see, there is no upper boundary for my x. So see, that moves up to infinite. Like that moves up to infinite point. So ranges are the same in this codomain, so it is 1, 2. So now we need to see that part. Where it is 1, 1 and 1. Now see. It's pi by 2 minus pi by 2. You can see that dark line is drawn. 10 is not defined at minus pi by 2, as well as not defined at pi by 2. Now you can see that for this part, with this part it is 1, 1. So if we restrict the domain of n function, open interval minus pi by 2 to pi by 2 to r, in that case that function is 1, 1 and 1. And therefore, where tan inverse? Tan inverse is from R to open interval minus pi by 2 to pi by 2. Here. Now you can see that for this part, see, from here to here. Here, except minus pi by 2 to pi by 2. So this part, see. This is the graph of tan inverse x, y equal to tan inverse x. Just we have to rotate it. If we rotate it and change the axis, then we get this graph. Now, how we are going to remember it? Tan of tan inverse some angle is equal to something only when that something belongs to where? Only where that belongs to R. For any real number it is defined. So we can write tan of tan inverse 2021, that is equal to 2020, because that is in R. Okay. Next one. Tan inverse of tan some angle is equal to some angle. And that thing is possible only where that some angle is between minus pi by 2 to pi by 2. That line in this open interval minus pi by 2 to pi by 2. Keep these two standard forms in your mind. Clear? See, this is the definition for tan inverse. Now let us see. This one is for inverse. Now see, basically quotation function from where to where? R minus v pi k belongs to z to R. This is the basically definition of what function. See, why we are removing this one? Because cos over sin, sin is 0 and that should be not there. So this is the reason why we are separating this thing. Now, if we need to restrict the domain from where to where? See, what from? You can observe that. See, for this part, here, see, 0 to pi. Clear? From 0 to pi. You can see that. That is 1, 1 and 1, 2. So for basic part, see that. Chord is not defined at 0 as well as not defined at pi. So open interval 0 to pi to r. If we restrict domain in this way, then that function is 1, 1 and 1, 2. So what inverse exists from where to where? R2 open interval 0 to pi. Now see here, for this part, here fx and x is there, x is equal to 0 to, dark line x is equal to pi. See here it is 1, 1 and 1, 2. So cos function is 1, 1 and 1, 2. What inverse is there? 1, 1 and 1, 2. So inverse exists. Now see here, cot inverse is equal to some angle is equal to some angle. Only when that some angle belongs to R. And same time, cot inverse of cot some angle is equal to something. Only when that belongs to open interval 0 to pi. Clear? Keep these two standard form in a mind. Okay? So keep this thing in mind. So these are the definition of inverse trigonometric forms. Let us see here. See. You can see that sine is from where to where? Close interval minus 1 to close interval minus pi by 2 to pi by 2. And here if you want to write sine for sine, then sine from close interval minus pi by 2 to pi by 2 to close interval minus 1 to 1. This function is 1 1 and 1 2, so inverse is this one. Same way cosine is from where to where? Close interval minus 1 to close interval 0 to pi. So cos from close interval 0 to pi to close interval minus 1 to 1 is 1 1 and 1 2. Likewise cosec inverse, sec inverse, tan inverse and cot inverse. See, these are the definitions of inverse trigonometric forms. Now see, in case of trigonometric form we need a standard forms. Likewise here standard forms are also there. Of course here a exercise is also given before standard form, but that thing is easy if we see the standard forms. So I would like to prove that standard forms for you. Let us see here. First one. Now see. Here it is given sine inverse minus x is equal to minus sine inverse x. Only when that x belongs to close interval minus 1 to 1. Same way cosec tan inverse minus x is equal to minus tan inverse x, x belongs to R. Cosec inverse minus x is equal to minus cosec inverse x whenever mod x is greater than or equal to 1. Here, how to prove it? One by one I would like to prove it. See, for the first part, suppose sine inverse x is equal to y. Where is x? X is from minus 1 to 1. And what can you say about y? It is from close interval minus pi by 2 to pi by 2. Here. Now, and therefore, x is equal to sine y. Now see. We want sine inverse x minus. So minus x is equal to minus sine y. So minus x is equal to sine of minus y. Why? Because sine is odd function. Now see here. Now see, x belongs to close interval minus 1 to 1 means what? Mod x belongs to close interval. Sorry, there is no need to check that thing here. Imply minus 1 less than or equal to x less than or equal to 1 multiplied by minus 1. So 1 greater than or equal to minus x greater than or equal to minus 1. So once again, minus x is also between minus 1 to 1. Clear? And where is y? Y is from close into minus pi by 2 to pi by 2. So y belongs to minus pi by 2 to pi by 2. This implies minus pi by 2 less than or equal to y less than or equal to pi by 2. Clear? If we multiply by minus 1, what we get? Pi by 2 greater than or equal to minus y greater than or equal to minus pi by 2. So where is y? Y is from minus pi by 2 to minus y also lies in between minus pi by 2 to pi by 2. So take sine inverse on both sides for this one. And therefore sine inverse of minus x is equal to sine inverse of sine minus y. And that is equal to minus y, because minus y belongs to where to where? It is from minus pi by 2 to pi by 2. So sine inverse minus x is equal to minus sine inverse x. And where is x? X is from close interval minus 1 to 1. This is the standard one, result number 1. Suppose we wish to find value of sine inverse minus half. One way it is true. How? Sine inverse of sine minus sine pi by 6. So that is equal to sine inverse of sine minus pi by 6. Clear? Yes. So that is equal to minus pi by 6, because sine is what function here. Minus pi by 6 belongs to that. This is the direct without using this standard form. But if we use this standard form, then sine inverse minus half is equal to minus sine inverse half. So that is equal to minus sine inverse sine pi by 6. And that is equal to minus pi by 6. We get direct way. That means proof is easy if we apply the standard forms. Clear? Next our aim is to prove second part, tan inverse minus 6. Second part we want to see. Tan inverse minus x is equal to minus tan inverse x. X belongs to R. Here, on same line, suppose tan inverse x is equal to y. Where is x? X belongs to R, y belongs to open interval minus pi by 2 to pi by 2. So x is equal to tan y. So minus x is equal to minus tan y. So minus x is equal to tan of minus y, because tan is odd function. Now x belongs to R, so minus x is in R. Y belongs to closed interval minus pi by 2 to pi by 2. So minus y also lies in same interval here. So take tan inverse on one side. Tan inverse of minus x is equal to tan inverse of tan minus y. And that is equal to minus y, because minus y lies in open interval minus pi by 2 to pi by 2. Replace value, that is equal to tan inverse x. So tan inverse minus x is equal to tan inverse x. Similarly, we can prove that, the proof is not in our syllabus. But without proof, it is not easy to explain standard forms. This is the reason I am proving. Next one is cosec inverse minus x is equal to minus cosec inverse x whenever mod x is greater than or equal to 1. Here. Now see here. Cosec inverse x. So suppose that cosec inverse x is equal to y. So mod x is greater than or equal to 1, and x belongs to where? Minus pi by 2 to pi by 2 except 0. So what we get? X belongs to, x is equal to cosec y. So minus x is equal to minus cosec y, and therefore minus x is equal to cosec minus y, because cosec is odd function. Now x is in this interval minus pi by 2 to pi by 2 except 0. Then minus x also lies in same interval. Now mod x is greater than or equal to 1. Mod magnitude of mod of negative x is also greater than or equal to 1. So we can take cosec inverse on both sides. So take cosec inverse on both sides. Cosec inverse of cosec minus y, and that is equal to minus y. And so take minus y is equal to minus cosec inverse. So this is the standard form number 3. Now see here. In this slide, see, these 3 forms is most important for us. Before solving the example, let us see these 3 forms over there. Now let us see next 3 forms. That is also important for us. See here. See. Cos inverse minus x is equal to pi minus cos inverse x. See here. Suppose cos inverse x is equal to y. Where is x? X is minus 1 to 1. What can you say about y? That is from closed interval 0 to pi. That we know. So x is equal to cos 1. So minus x is equal to minus cos 1. Here important thing is that, dear friends, see, and therefore minus x is equal to cos pi minus y, because in second quadrant cos function is negative. Cos is not odd function, so we can't write cos minus 1. Now we have to see that part. X belongs to closed interval minus 1 to 1. So minus x is also in same interval minus 1 to 1. Now we have to see this angle. 0 less than or equal to y less than or equal to pi, because y belongs to closed interval 0 to pi. And therefore, let us see it. 0 greater than or equal to minus y greater than or equal to minus pi. Minus pi less than or equal to minus y less than or equal to 0. Add pi. So pi minus y less than or equal to pi. Now it is in range. So we can take cos inverse on one side. So cos inverse of minus x is equal to cos inverse of cos of pi minus y. Now that is equal to pi minus y. Why? Because pi minus y is in range 0 to pi. Replace value of y, that is cos inverse x. So this is the second form. See, cos inverse minus x is equal to pi minus cos inverse x. Suppose we wish to find, for example, cos inverse minus 0.5. So cos inverse is minus half. So what we have to write here? Cos inverse of cos pi minus pi by 3, that is 2 pi by 3. Yes or no? But if we apply this form, then that is equal to pi minus cos inverse half. So pi minus cos inverse cos pi by 3. Now in this case, see, cos 2 pi by 3 is there. That is directly 2 pi by 3. Why? Because 2 pi by 3 lies in 0 to pi. Yes. Now here pi minus pi by 3. And that comes out 2 pi by 3. So better to apply standard form to find values. Next standard form is given sec inverse minus x. Sec inverse minus x is equal to pi minus sec inverse x mod x is greater than or equal to 1. Clear? So for this part, what we have to do? Suppose sec inverse x is equal to y, mod x is greater than or equal to 1, X belongs to where? 0 to pi except pi by 2. So what can you say about x is equal to sec y? So minus x is equal to minus sec y. So minus x is equal to sec of pi minus 1. Yes or no? Sec important. And see, sec is not common. Sec is given. Now, see here. Pi minus y is that. Y belongs to closed interval 0 to pi except pi by 2. So minus y also belongs to that. Why? Because of C here. See. Y belongs to 0 to pi except pi by 2. So minus y belongs to minus pi to 0 except minus pi by 2. So pi minus y belongs to 0 to pi except pi minus pi by 2. And that is pi by 2. So pi minus y also belongs to in same range. Mod x greater than or equal to 1. So magnitude of minus x is also greater than or equal to 1. So we can take sec inverse on both sides. And therefore sec inverse of minus x is equal to sec inverse of sec pi minus y. And that comes out pi minus y. Now replace value of y. What is the value of y? Sec inverse x. So we get sec inverse minus x is equal to pi minus sec inverse x. See, third one, cot inverse minus x is equal to pi minus cot inverse x. So let us see that part. Cot inverse minus x is equal to pi minus cot inverse x. Suppose, and here x belongs to r. Suppose cot inverse x is equal to y. So x is equal to cot y. What can you say about y? Y where to where? For cot inverse, that is 0 to pi. Cot inverse from 0 to pi except pi by 2. And therefore minus x is equal to minus cot y. So minus x is equal to cot pi minus y. Clear? Now one thing. For cot inverse basically ranges. See, basically ranges where to where? Open interval 0 to pi. Now see, 0 less than or equal to y less than or equal to pi. Sorry, open interval. So they implies minus pi less than minus y less than 0. If we add pi, then 0 less than pi minus y less than pi. So it is in range. X is in R. So minus x is also in R. So we can take cot inverse on both sides. So cot inverse of cot inverse of minus x is equal to cot inverse of cot pi minus y. So that is equal to pi minus y. So that is equal to pi minus cot inverse x. So these are the standard forms. Here, dear friends, let us see. You are not going to learn the proof of this result, but proof is useful to solve problem section later on. So these are the more 3 standard forms. Here, previously we already seen some standard forms also. Now see here. Today we are going to see up to this time. Next time we are going to see more examples.